Modern military technologies are advancing faster than ever, ushering in a new era of sophisticated systems that will transform future missions. In this video, we examine the groundbreaking platforms defining the next generation of defense operations. From autonomous vehicles and intelligent surveillance to high-precision strike capability and long-endurance unmanned aircraft, these innovations expand the limits of speed, accuracy, and situational awareness, revolutionizing how modern forces function in the field. Get prepared to uncover the technologies that are driving the next major leap in defense capability and reshaping the battle space ahead. Bayraktar TB2. The Bayraktar TB2 is a long-endurance, medium-altitude UAV developed to deliver reliable intelligence, surveillance, and precision strike capabilities. Built with an efficient aerodynamic design, it can stay airborne for extended periods while carrying multiple mission payloads, including electro-optical sensors and laser-guided munitions. Its onboard avionics enable autonomous taxi, takeoff, landing, and waypoint navigation, reducing operator workload. Paladin Drone. The Paladin drone platform is built for rapid deployment, autonomous flight, and real-time situational awareness in high-pressure environments. Originally engineered for first response missions, it uses LTE-based connectivity to fly beyond visual line of sight, launching instantly from automated drone stations and streaming live video to operators within seconds. Its advanced software suite delivers precise flight control, automated reporting, and seamless coordination with ground teams, making it ideal for emergencies, search operations, and tactical monitoring. In defense roles, Paladin is evolving into a counter-UAS interceptor capable of detecting, tracking, and neutralizing hostile drones using integrated radar and computer vision sensors. Designed to act as an autonomous aerial wingman, it strengthens perimeter security, reconnaissance. Delta Black Raider 330. The Delta Black Raider 330 is a next-generation Group 3 unmanned aerial system engineered to maximize endurance, payload capacity, and mission versatility. Powered by a hybrid electric propulsion system, it delivers efficient vertical takeoff and landing without the need for a runway, making it perfectly suited for remote, austere, or improvised environments. Its long-duration performance enables extended intelligence, surveillance, and reconnaissance missions with exceptional reliability. The aircraft features advanced low-noise propellers developed through specialized engineering collaborations, boosting aerodynamic efficiency while lowering acoustic signatures for stealth-focused operations. With a payload capacity of over 100 pounds, it supports multi-sensor packages, communication systems, and modular mission kits tailored to operational requirements. A digital maintenance ecosystem streamlines field support by offering interactive diagnostics and reducing downtime. Combined with its modular open architecture, the Raider 330 can rapidly transition between ISR, logistics, and other mission profiles, delivering a powerful, flexible platform built for modern military and tactical demands. Arex Systems EXSMU-1. Meet the Arex Systems EXSMU-1, one of the most agile unmanned aerial systems ever engineered. This powerhouse uses a patented omnidirectional propulsion system that lets it fly inverted, pivot instantly, and stay rock-steady even in heavy winds. It pushes speeds up to 200 kilometers per hour and carries payloads up to 1.5 kilograms, perfect for sensors, cameras, or even tactical tools. With 32 modular attachment points, it adapts instantly for ISR missions, counter-drone operations, loitering tasks, or close-quarters support. STM NADA 300. The STM NADA 300 is a cutting-edge autonomous underwater vehicle engineered for long-endurance missions beneath the surface, combining reliability with precise navigation. Its modular design supports a wide range of payloads, including side-scan sonar, synthetic aperture sonar, and environmental sensors, making it adaptable for mine countermeasures, reconnaissance, and seabed mapping. With a streamlined hull for efficient underwater travel and autonomous mission planning, the NADA 300 can operate independently in challenging conditions. It is designed for rapid deployment by just 2 personnel, allowing easy transport and swift field use. Capable of extended missions, The NADA 300 conducts detailed underwater surveys and collects critical data for naval operations. Its versatility spans reconnaissance, inspection, and scientific research. Rheinmetall Fuchs JDRM. The Rheinmetall Fuchs JDRM is a powerful, missile-equipped ground vehicle designed to deliver high-precision, mobile strike capability through a vertical launch system built on the proven Fuchs platform. It features upgraded electronics and enhanced protection while incorporating a formidable long-range firepower package. Leonardo Proteus. The Leonardo Proteus is a next-generation uncrewed rotorcraft designed for naval and expeditionary missions that demand long-range, autonomous vertical flight. Developed in collaboration with Leonardo, the UK Ministry of Defence, and the Royal Navy, it acts as a key technology demonstrator for future large VTOL platforms. Proteus features a modular payload bay capable of carrying standardized mission pallets, enabling rapid configuration for anti-submarine warfare, maritime surveillance, logistics support, transport operations, or advanced sensor deployment. Its digital twin development environment allows engineers to refine autonomy, flight control laws, and mission behavior through extensive simulation before physical testing, improving reliability and reducing development risk. The aircraft uses advanced AI-assisted flight planning. Shield AI XBAT. The Shield AI XBAT is an advanced VTOL combat aircraft built around full artificial intelligence autonomy, enabling it to fly, navigate, and execute missions without relying on GPS or human pilots. Powered by the company's HiveMind system, it is engineered to operate effectively in contested environments where communications are degraded or denied. Its vertical takeoff capability allows launch from small ships, remote islands, or improvised forward bases without the need for a runway. The aircraft supports mission payloads while delivering a range of over 2,000 nautical miles, providing the reach required for deep operations. Its compact airframe enables high-altitude flight above 50,000 feet and includes internal bays and external hardpoints for strike, ISR, and electronic warfare missions. Designed to function as an autonomous wingman or operate fully independently, the XBAT combines smart autonomy with long-range endurance and multi-role adaptability. It marks a significant advancement in next-generation unmanned combat aviation. Scout AI Nomad. The Scout AI Nomad serves as an advanced unmanned ground vehicle engineered for autonomous missions where real-time decision-making and silent mobility are essential. Powered by the Scout's Fury autonomy system, it functions smoothly even in environments where GPS or communications are unavailable, using passive vision sensors to navigate and interpret terrain. Its compact, efficient hardware architecture enables long operational cycles while keeping power consumption low.